Hello everyone and welcome to our video tutorial about SpotMAX. So what is SpotMAX? SpotMAX is a software framework that you can use to analyze multidimensional fluorescence microscopy data. And it has two main functionalities. One is about spot detection. It can detect globular-like structures that appear in fluorescence microscopy data as spots, so these fluorescent spots that you see often in many images. And the other function is to segment and quantify a reference channel. The reference channel is any subcellular structure that you have labeled in the cell. So, for example, the nuclei can be the mitochondrial network, can be chromosomes, can be whatever non-spot-like structure you can have. So for the spots, they need to be reasonably small and kind of circular. Plus, it would not work well if you have a massive variation in size between the different spots. But we will see later with some examples. So in this video, I will not cover the installation of SpotMAX because we have detailed documentation. But if you think a video could help, then don't worry. You can ask, and we can think about having a video also for the installation. So for SpotMAX, it's based on Cell-ACDC. For that, we have already another video tutorial. I will put the links in the description so that you can also check that. This video assumes you are kind of familiar with Cell-ACDC. And if not, I recommend first looking into Cell-ACDC because you can use that software for segmenting your cells first. SpotMAX is dedicated more for the subcellular structure that you might have. As I said, we will not cover the installation, so let's just start with looking at the parameters. So in this video, I was planning to cover the parameters that are needed for setting up an analysis. There are lots of other aspects of the software, but we will cover those in the next videos. So for today, we will go through basically the parameters that you can set up so that you can analyze your images. So the first thing is obviously to run SpotMAX. For that, we need to use the terminal. That's probably the only time that you will interact with the terminal, except for confirming few details when you actually run the analysis. I'm using the PowerShell. I'm on Windows, but you can run SpotMAX on Windows, Mac, or Linux. You will have different terminal. On Mac, you have to use the terminal app. On Windows, I recommend installing Miniforge and using the Miniforge prompt. Here, in my case, I'm using the PowerShell, but it really doesn't matter. So we go ahead. Usually, I recommend using a conda environment. So for that, we type conda activate ACDC, which it's where I have SpotMAX installed. And then to run SpotMAX, you can either run it through ACDC or directly as typing SpotMAX. In this case, we go through ACDC, which is anyway recommended. So we fire up Cell-ACDC. As I said, you should be familiar already with the ACDC software in order to move on to SpotMAX. Okay, so Cell-ACDC is now open. I'm going to bring it here. And one thing was small suggestion, always keep an eye on the terminal every now and then. If things looks weird or stuck or the graphical user interface is not responsive, keep an eye on the terminal because there might be messages that you can debug from there or simply send them to me so that we can eventually fix issues. So to fire SpotMAX, to launch SpotMAX, if installed correctly, you will have this additional button here, launch SpotMAX. If not, if this button doesn't appear, something went wrong with the installation or you simply don't have it installed. Make sure it's installed in the same environment where you also have Cell-ACDC installed. As you can see here, I have Cell-ACDC in the ACDC environment and I have this now launch SpotMAX button. So we press this button and we get the graphical user interface. So for those of you familiar with Cell-ACDC, this is the same user interface. The only difference is that you have these parameters on the left. When you hide it, it looks exactly like the Cell-ACDC Module 3 GUI, but the parameters are what makes the SpotMAX basically running. So it's kind of a plugin for the ACDC GUI. So here you have these parameters side of the window, and you have the analysis parameters, tune parameter, and inspect or edit results. So in this video, we are going to cover the analysis parameters. In the next video, I'm going to show you how you can inspect and visualize the results. And maybe in another video, we will go through the tuning of the parameters. So what are the parameters? They are all here that you can scroll. I know they look like a lot of parameters, but most of them are self-explanatory basically. So you need to tell which path you want to analyze, which one is your spot channel, the metadata, the number of frames that you have if you have time-lapse, number of z-slices and stuff. So there's very few parameters that are critical for the analysis, and I will make sure that I will underline when we get to those. So the third thing that you have to do here, so you have to set up these parameters. So we have documentation that explains all of these parameters. They are not only on the documentation, which I will link down in the description. They also have this info button that you can click, and you get the same exact explanation that you would get for each one of these parameters from the documentation. So, but let's go through the parameters one by one. We also have a couple of tutorials on the documentation, which guides you through setting up the parameters from a preset set of parameters, essentially, that we have as examples for mitochondrial DNA detection. So those nucleoids, if you want to analyze those kind of images, you probably are familiar with what I'm talking about. But also we use it a lot for single molecule fish. That might be a little bit more of a broader application. So we have a tutorial for that as well. But let's go through the parameters. So here we have file path and channels. Here is where you will set, basically you will tell SpotMAX where are your files, where are your images. So experiment folder path to analyze, these are the list of folders you want to analyze. And when I'm talking about folders, let me grab an example of folders here. So as an example, we can take the single molecule fish in yeast, in this case, data that we actually already have as a tutorial on the documentation, which would look like something like this. So here you can see position. So these are the positions. As I said, you should be familiar with the Cell-ACDC, so you should be already familiar with this type of structure. And for this is what I usually refer to as the experiment folder, this SM fish yeast. And the experiment folder is that folder that contains multiple positions, and which is why here it says experiment folder path or paths. So if you have multiple ones to analyze. So there's no limit to the amount of folders you can analyze in a single run. You can analyze a single position, you can analyze a single experiment folder with multiple position, or you can also analyze multiple experiment folder. And one thing, if you put here a folder that is not an experiment folder, but something higher up, for example, SpotMAX will automatically scan that folder and find all of those experiment folder paths so that it lists them for you, basically. But I would not do it. I would just simply add one by one. So the position folder is here. The position folder must have the images folder, and the images folder you have all of your files from Cell-ACDC. The first thing to do before going into SpotMAX is anyway segmenting the cells, so I recommend that you do that. You can use SpotMAX without segmenting the cells, but the performance will be a little bit worse because then the background will be different. The background for the spots, if you have the cells, will be inside of the cells, but outside of the spots, which usually is a little bit more accurate than the background that is just outside of the spot because there's no information of what the cells are. So after you segment the cells, it's probably best to, it's anyway best to segment the cells first. So let's say I want to analyze this position. So basically what I do, I can go here, click on this little button here. You get this dialog where you can add folder, and here you can add as many folders as you want, as I said. So we will go to this location that I already prepared, the same position to images. And as I said, we can set this single molecule fish folder. We can say analyze a specific position. Also the images folder doesn't matter. You can. So let's say we want to analyze this. There could be multiple positions here. In this case, we have only one. We say select folder, and now it's here. And if you want to add more, we would just add more positions or more experiments. And here we say OK. So here now you have this folder that you want to analyze. So now we need to set the spots channel end name, and this is the last part of your file, of the files that identifies the spot channel. So if you look at the files I have again, you see here there is a base name. The base name is what is the same as for all the files except for the recovery folder. And then the base name usually ends with underscore, and there are different end names. So when you see the word end name, we refer to that. When you see base name is the first part that is common to all the files. So what we can do here is we need to know which one is the spot channel, which in my case is mdn1.tiff. So we can go here and say mdn1, and we don't need to say .tiff because SpotMAX knows that it needs to load the TIFF files. They can be also MPZ aligned MPZ files, so you shouldn't worry about that. It will be automatically picked up. Cell segmentation endname, if you have it, I highly recommend having it. In my case, it simply ends with segm.mpz. As I said, you don't have to set the extension because SpotMAX knows about segmentation files that are MPZ. So in my case, I set it to segm, which is the segmentation file that I created for the cells, but it could be a segmentation file of any other structure object that basically contains your reference channel or your spot channel. Reference channel end name is not required. So one thing you can do with SpotMAX, as I said, is analyze the spot channel or a reference channel or both. So if you don't have a spot channel, you just want to use it as a reference channel segmentation, just place here the reference channel and don't load anything here. If you have a reference channel, then like in my case, I have a spot channel MDN1 and I have DAPI staining for the nucleus, which I want to segment with SpotMAX. So we go here and we say DAPI. So now I am basically loading the parameters manually one by one, but one way you can do a little bit faster so that you have preset parameters is to actually load that image into SpotMAX directly, as you would do for Cell-ACDC. The only difference is that often in Cell-ACDC you load the signal of the cells. In SpotMAX you will load the signal of the spots or the reference channel depending what you want to analyze. So in my case I want to analyze the spots, so I can go here, select single molecule fish yeast. It asks me which position I want to load, so I will load position 2. And here, instead of selecting the channel for the cells as you would do with Cell-ACDC, you actually load the spot channel, so MDN1. Now you can select the segmentation file of the cells. So in this case, we have only one, which is the cells, so we can load segm. We go through the usual dialogues, and now many of the parameters are already filled up. So in this case, it would have set position 2, which is what we set manually, but since we loaded it, we have it already set up here. The spot channel is MDN1. As you can see, it created for segmentation. It added the extension. The extension can be there or can be removed. It really doesn't matter. And now we can continue with the rest. So we have here reference channel endname, which is DAPI for me because I want to segment DAPI. If you want to have a look at DAPI, you can also load it as an overlay from here. This is all more like about ACDC because it's the same user interface. So we can continue. Spot channel segmentation endname. You would put here the endname of a file that you created to segment the spots first, because SpotMAX works by 3 steps. One is segmenting the spots, one is detecting the spots on top of the segmentation of the spots, and one is the quantification, where it computes the size, the intensities, and all kinds of features. So intensity, size, and so forth. So these steps are modular, which means that you can perform them outside of SpotMAX. I don't know if you have any other software, maybe an Apare plugin, maybe with Fiji, maybe with Elastic. You segment the spots there, save them as either MPZ or TIFF. So TIFF should be kind of universal, and save them as, I don't know, spots MDN1 segmentation. Then you save them into the images folder, and you would be able to put it here, say MDN1 segmentation. So then you have you can use SpotMAX just for the detection and the quantification. Same goes with the reference channel. SpotMAX will segment the reference channel if you want, and but if you already segmented it outside and you want to just use it to, I don't know, let's say count the number of spots detected by SpotMAX that are inside the reference channel, and you already segmented the reference channel outside of SpotMAX, you can save that file and provide it here, so SpotMAX will not segment the reference channel, will use whatever you provide. Same goes for the spot coordinate. If you already detected the spots and you created a table with x, y, z coordinates, you save that table into the images folder, provide the table hand name here, and actually I think that here you can also put them in the SpotMAX output folder, but for that I need to double check. But let's say you already detected the spots outside of SpotMAX, you can provide a table here, and SpotMAX will just skip the detection. We go straight into quantify those spots, like the size, the intensities, and so forth. So for the table with lineage info, here, if you're familiar with SCDC and you work with yeast data, but also with other mammalian cells, for example, and you paired mother with buds for yeast or mother, daughter, daughter, it's probably beneficial. For yeast, it's kind of mandatory because the buds usually don't have any signal, but they're segmented separately. So you want to pair the mother with the bud. So in this case, this one with this one, which exactly we already have prepared in this data set. We annotated this in ACDC, so we can move here. However, you need to tell SpotMAX where this information is. And for that, you can either just type the table, or you can always with these click here, go to inside and say that my table is the one for ACDC. Those annotations are in the file ending with ACDC output CSV, which corresponds to segmentation MPZ. If you rename the segmentation file with the ACDC, you call it, I don't know, segmentation cells, then this file will be called ACDC output cells, because for each one of the segmentation files, you can have this table. So we just select this, and as you can see, recognize the end name. I could have just typed ACDC output, but if you don't know, or you want to just click here, it will automatically set the ACDC output here. And this is kind of mandatory for mother buds, because then the bud don't have signal. It's better to quantify them together with the mother cell. So the run number, this is a number that will be prepended to the output files of SpotMAX. So this is one of the ways you can run multiple analysis and get multiple output files from SpotMAX, so that you can run as many as you want, testing different kind of parameters and see what looks best. You don't have to overwrite the previous analysis. You can just increase the run number here and you get 1, 2, 3. However, these can be not super friendly if you don't annotate down what 1 was, what 2 was. You don't have to do that, because you can also append at the end of the output files a text. So let's say you try a different parameter, you type here a description. So for me, it can be tutorial. So I know that the files that are ending with tutorial are the files that we're generating now during this tutorial, but they could be any text you want to append. Just a very important thing, this doesn't mean that files that have run number 1 with a different text will not all be overwritten. So what sets the files you get is the run number. So if you have files that have run number 1 tutorial, and then you have other files that are run number 1 and a different one, let's say tutorial 2 or something else, the files that are all with run number 1 will be overwritten anyway. So what gives you the files is the run number. This is just for you to add a description to those files. But you cannot have the same run number with different text appended at the end of the output file. So this is really important. The file extension of the output tables, there are 2 options. Go for H5 only if you are willing to analyze your data with Python, and or if it's large data, like if you have time lapse, many frames, many cells, then CSV kind of are limited in that case. But to be honest, probably just go with CSV, because then it's much easier. You can open them in Excel, you can open them in GraphPad, you can open them in any other file, any other software analysis software that you want. So we changed this to CSV, and as you can see, these are mainly self-explanatory files, maybe not that self-explanatory, but at least it's nothing hard to understand. The metadata would be not filled out if we didn't load the cells, the files. But if you have correct metadata from Cell-ACDC, as you can see, it has been picked up from SpotMAX, already placed here for me. The only thing is that I know the spots reported emission in this case was a little bit higher. It was probably something like 5 or 9. And so the number of frames, I don't have time lapse in this case, so leave it at 1. Analyze until frame number. If you have time lapse and you want to analyze less frames that there actually are, you just set it here. Number of Z slices, if you have 2D cells, 2D images, or 2D images over time, here you would set 1 if you have 2D images, but in my case I have 3D images. As you can see from here, you can see the spots popping up that I want to detect. And the number of Z slices here we set it to 25 because that's what I have. Pixel width in micrometers, pixel height in micrometers, voxel depth in micrometers. Numerical aperture, this is important for the calculating this diffraction limited spot. So place the numerical aperture of your objective. If you don't know it, to be honest, 1.2, 1.3, 1.4 will probably be a very good guess. So the spots report emission wavelength as well for the minimum dimensions, as you can see, from the diffraction limited spot. So if your spots are diffraction limited, you can let SpotMAX calculate this automatically, but to be honest, you can also modify manually, so it really probably doesn't matter in this case, but stay in the range of 500 if you don't know the emission wavelength, but it should be very easy to just Google. So spot minimum Z size, this is one of the important parameters. So as you can see here, it's calculating the spot ZYX minimum dimension. So this is the radius, and you can visualize that by clicking this compute step, which I will talk about later. There are some steps, some parameters that can be pre-visualized. And here it says 4 by 3 by 3 pixels roughly. It's calculated from the diffraction limit. If you think your spots are larger than this, you can change the resolution multiplier. However, you don't have to do this like manually. You can do it like visually at least. So you go to the tune parameters tab. I said I will not talk about this, but we need it just for now. It can do many more functions, but the simplest you can do here is to start adding points. You see there is a circle now. We go to the center of this spot, for example, let's say here, and we can see that the minimum spot that I have is a little bit too small maybe. So in that case, what you can do, and this is because it was acquired with bright field, so the spots are actually a little bit larger than diffraction limited. They are diffraction limited, but you don't get the absolute resolution from wide field images. So here you can increase by going up and down with the arrows on your keyboard or by pressing this button. When I press up and down, it's easier because the spot stays there. If I have to go there and click, then I need to come back. And as you can see, it's changing the resolution multiplier, which means these spots are actually maybe 1.5 or twice the resolution multiplier. So the diffraction limit, so the minimum spot you will be able to resolve with confocal microscopy, so not super resolution. If you have super resolution actually, and you have smaller spots, you probably go below the resolution. So you can go below to 0.5, 0.7. The steps with plus and minus are 0.5. If you need granular control, you can just type it. And let's say I'm pretty happy here with 2. I don't have to do anything. I don't have to add this spot. When I go back here, you will see that the resolution multiplier has already been changed automatically. So my spots now are 4 pixels in Z, 6 and 6 roughly radius, as you can see, 1, 2, 3, 4, 5 pixels in X and Y. So this is important because if the spots that you detect in the same place, so let's say you have one spot, but then SpotMAX detects 2 spots in the same place, it's probably because you have set a spot size that is too small, so multiple spots can be detected within the same structure, let's say, within the same spot. So if you have that, you probably have to increase the spot size by increasing the resolution multiplier. And if instead you don't detect enough spots in a spot, it could be that you simply had this spot minimum dimension smaller, because this what it does, it says to SpotMAX, do not detect two spots within the same volume, within the same minimum dimension that I'm providing. And if you're curious about this, you can click here. You see this is the kind of the footprint of the minimum, the smallest spot that you can have. And you can see this is actually 6 in diameter because of the diffraction limit. The way it works, you need to go by radius, but you don't have to care too much about these details. And you get this 6. Now, in Z, there is no visual way to do this, in the sense there is no clicking. You have to do it kind of manually. So you can basically go to one of your spots and count how many slices it takes to disappear, basically. So let's say the spot appears here. So we say 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 pixels roughly, 9 Z slices from start to finish, so diameter, which means in radius 4 is pretty much correct. So which means I have 1 micrometer minimum Z size to change. If I need to change this, let's say they are actually smaller, I can go to 0.5 and they get to 2 pixels. If you go to something absolutely crazy like 0, which doesn't make any sense, you get this warning button that you click and it tells you one of them is smaller, so then 2 pixels. We recommend increasing the radius to at least 3 pixels. If your spots are in radius smaller than 3 pixels, I probably recommend to acquire your images again. I would try the detection anyway, but it's probably like better to acquire your images with a little bit more pixels, because 3 in radius is kind of the minimum you should acquire. The 0, of course, doesn't make any sense. You can probably run the analysis, probably would give you errors, but you get this warning, so just be careful. So as I said, for me it was 1.0. So, and we are done with this part. So this is kind of crucial. You can tweak these depending on whether you detect more spots or less spots than you expect. It's not the only reason for those, but it's one of the reasons that you might want to try different run numbers with slightly different sizes. Okay, so we can move on to pre-processing, where this is a step that is done before detection, before segmenting the reference channel, and it's valid for both the reference channel and the spots channel. And the first is aggregate cells prior analysis. So this means that SpotMAX will put all the cells together in a single image of your image if you have this active, which means thresholding or segmentation is done on an image that has multiple cells. And if this is kind of mandatory if you have cells that have no spots at all compared to cells that do have spots. In this case, it's the only option, because you want to make sure you compare the cells without spots with cells that have spots, so that you know kind of the threshold that should be used, while the single spot would not have that, the single cell would not have that information. So in any case, I recommend trying on and off both. So since you have the run numbers, you can have one run number with aggregate cells, one run number without aggregate cells, and this is true for any of the parameters. I recommend always to try them. If you turn it off, it means whatever segmentation you're running, it will run on every single cell separately. So this can be way more accurate if you have large variations of intensities between all the different cells, so that the thresholding can be applied on every single cell. However, if a cell does not have any spot, I'm not talking about the buds, because the buds will anyway be segmented together with the mother, but the cell doesn't have spots, then thresholding usually brings a lot of false positives that you can filter out later. So it's not that it doesn't work, but it might be not the best option. Anyway, as I said, try both on and off and see how it goes. Then this option here, threshold only inside segmented objects, means that you are not considering the background that is around the cell, because the cell is cropped in a bounding box. So if you have very bright features from a neighboring cells that are leaking into your current cell, then it might be worth having this on. I would just keep it on. Remove hot pixels. It's a filter that it does remove hot pixels, which are these bright single pixels isolated. And when you get to these kind of parameters, you will have this compute button. And when you click this compute button, which we can click in a second, you will see the result of this exact step so that you can kind of visualize yourself whether it works or not. I don't think I have an example here. I would have an example of a hot pixel that you can see here. This is actually outside of the cell, so it doesn't matter. We will not see the result. But if this hot pixel was inside the cell, which I don't think I have in this example, but if it was inside of the cells, remove hot pixel is kind of mandatory to avoid artifacts. And we can click on this and we see the result of removing the hot pixels on the left and on the right. You see that all of those bright single isolated spots here, pixels are removed from the image. So usually it improves stuff and it makes things a little bit clearer for the detection. And here you see the image on the left and the filter applied on the right. Okay. Gaussian filter, it's usually recommended to have a small pixel, small sigma for the Gaussian filter. The higher the sigma, the more blurring. Gaussian filter is a filter that removes noise, but it's also blurring the edges. So a small sigma usually makes things better, and we can look at it by, see, you see that on the right the noise is way better, it's being removed, and everything looks blurrier but also sharper at the same time, in the sense that noise is removed, so everything looks a little bit better. So I recommend having the sigma. One thing you can do with this sigma is that you're not constricted to have only a single value, which would be applied to all axes. But since often we have z stacks that are anisotropic, meaning that the voxel depth is usually way bigger, at least 3 times bigger than the pixel depth. In my case, I have 240 nanometers, 0.24 micrometer voxel depth. So this is the distance between every single z slice. And I have 70 nanometer, 72 nanometer, which is roughly a third of my voxel depth, a little bit less than a third. But it means that the Gaussian filter might be applied differently in the voxel depth, because if I'm applying 0.75, it means I'm taking into account almost 10 pixels for y in y and x, and only 3 pixels in z. So what you can do, you can provide one sigma for each one of the axes in order z, y, x. So you could, for example, have 1.5, 0.75 and 0.75. It's not something you can really appreciate, but often is more correct, is more accurate to apply a slightly bigger sigma on the z-axis, which is this case. As I said, just try different values. It's not like crucial, but it can help to have some kind of Gaussian filter. Sharpen the spot signal prior detection means apply a sharpening filter, which is like a difference of Gaussian's filter. It's a common filter for spot detection, usually makes things just better. You can see the result here, that it makes the spots way sharper, and often that before were kind of invisible. You can see here now these 3 spots look much better on the sharpened filter. So usually I would recommend having it on. Extend 3D input segmentation objects. This one we can skip it, but it's if you have three-dimensional data that you segment in 3D, but you want to segment only the center Z slice of each object, then you can automatically extend this on top and bottom, but for now we can skip it. Okay, now we get to the reference channel. In our case, we want to segment the reference channel, so we turn it on. Obviously, it's not enough to activate the reference channel. You also have to tell SpotMAX where the reference channel is. So or where the reference channel endname is. So we have DAPI, we activate the reference channel and we go through the parameters. Segment the reference channel, whether you want to segment it or not, because the reference channel doesn't need to be segmented. It can also be used just as a intensity comparison between the spots and reference channel. So in my case, I want to segment the reference channel and keep only the spots that are inside the reference channel mask. This is very useful, for example, for mitochondrial DNA, where you want to detect the spots only inside the mitochondrial network, which is your reference channel. So in that case, you would turn it on. In our case, we want to know which spots are inside the nucleus, which spots are outside of the nucleus in the cytoplasm. So we don't want to keep only the ones that are inside the nucleus, our reference channel mask. So we turn it off. Remove the spots that are inside reference channel mask. This is the opposite. If you want only the ones that are outside the reference channel mask, you would turn it on. Use the reference channel to mask to determine the background. This means that if you turn it on, when SpotMAX will calculate the background will also be considered as inside the reference channel mask and not just inside the cells. So in the case of mitochondrial network, for example, it might be good to have the background to be the background signal of the mitochondrial network and not the background signal of the cells. So in that case, you would turn it on because you want to consider the background inside the reference channel mask, so inside the mitochondrial network and obviously outside of the spots. The reference channel is a single object. In our case, yes, it's just a single big nucleus. This helps to remove artifacts that are small things that get segmented as part of the reference channel, but they are not obviously the nucleus. And in this case, SpotMAX will keep the largest object for each one of the objects of the reference channel. Then we have keep external touching objects intact. This can be helpful if your objects are slightly bigger than the reference channel, than the mask of the cells. So if it goes slightly out, for example, but you still want to calculate it, then it's easier to keep this one on, because then those things that come slightly out of the mask, obviously if they go completely out, they will not be kept. But if they go slightly out of the mask, it might be beneficial to have it on so you don't clip the reference channel mask around the masks of the cells, exactly around the mask, but you allowed for some kind of tolerance on the mask. Reference channel Gaussian filter, same things as before. It's usually helpful to have. Maybe you might want to have one per axis, where the one for the z-axis is slightly bigger than the one for the x and y axis for the reasons I explained before. And when you get to this compute button, you can click on it and see the results. Now this is not the spot channel. Now it's loading the TAPI channel. These are my nuclei that we can see here. And we can see that the Gaussian filter makes the nuclei to pop out better so that we can segment it better. Good. So now we are here. Sigma is used to enhance network-like structures. In our case, we don't have network-like structures, which are these tubular structure. In the case of mitochondrial network, this makes a massive difference. It makes things way better. And basically, it's not easy to choose a value, but we never used anything different than 1.0 and 2.0, or maybe 2.0, 3.0. So the more sigmas you use, the more refined the network-like structure will appear. But obviously you will start losing some details, so like a little bit more blurred. The higher the signal, the more blurred, and the more sigmas, the more blurred. But I recommend testing. In our case, it probably doesn't make much of a difference because these are nuclei, they're not network-like structures. So it will probably not make much of a difference. I actually never tried. It's a little bit of a heavy filter. And actually you can see that it tries to do something. So it tried to make the nuclei to look a little bit more like a network, but these are obviously artifacts. And that's kind of the thing of this filter. If you apply it to things that are not network, it still kind of hallucinate and gives you these networks. But it might actually help because these are lower intensity, these are higher intensity, so they will be get thresholded out. So it might still help, but I know that it doesn't make any sense, so I would just leave it at 0, which means deactivate. Okay, reference channel segmentation method instead. This is where you choose what method to use to segment the reference channel, where by segmenting we mean assigning each pixel whether they belong to the reference channel or they belong to the background. And there are actually three ways. Spotify will probably have to remove it because it's not for reference channel, but if you have a spot-like structure for reference channel, then you could use Spotify. And thresholding bioimage IO model means that thresholding means we use any of these thresholding methods. By thresholding means that a single threshold is selected as intensity threshold, so that everything above that threshold are considered reference channel mask, and plus some post-processing, like if it's a single object here, then the mask will be a single object, so there will be some post-processing. But mainly the segmentation is based on thresholding, and these are all the values. And in a second, we can look at all of them. But Bioimage.io model is this really cool community effort of models, like AI models, that you can simply go on the website, Bioimage.io. You can scroll through the images and see which one might look like your data. If you're lucky, someone already made a AI model to segment your structures. You can take down the URL, the DOI, the zip, and place it here. Bioimage.io model. I don't think I have the libraries installed, so I cannot show you directly. But basically, by clicking on this button here to set up the network, to set up the neural network, the AI model, you provide the DOI, the digital object identifier, or the URL of the model, and SpotMAX will use that model. In our case, I know that thresholding works well. However, there are many type of thresholding, many algorithms that you can use, and all of them have their own way to determine the optimal threshold. However, we don't need to try all of them blindly. We can test them here by clicking on this button. And here we get the result of all of them. And since we are interested in the nuclei that you can see here, we probably can see that threshold Otsu is doing the best job. As we can see here, it has still some of these artifacts here maybe on the Z slicer, but that's not much we can do about that. Maybe we can improve with more blurring, so that those makes go kind of away. You see now things should look smoother, exactly. So here we see things are smooth, and to be honest, most of the thresholding methods makes a really good job. So, and this is when your structures are really easy to segment. All of the thresholding methods agree, but usually I like Otsu or Lee, so we will go for Otsu with this kind of reference of this kind of Gaussian filter that, as you can see, does make a difference. So you kind of have to try a little bit with what you can do. So threshold Otsu is the one that has been already selected. Okay, now we're kind of done with the reference channel, except that if you need this reference channel is a little bit easy to segment, but if you need additional post-processing, you can set up features. So these are all the numerical features that SpotMAX will calculate about the reference channel, and they can then be used to refine the segmentation. So let's say you have 4 objects segmented and one is too small for being, and it's just an artifact. You could set a threshold on the size, and you do that by clicking on this button. You select the features. All the features are documented here. If you click on help, it will open the website, our documentation, where it tells you about these features and what they are, and you can use them. So for example, we can go to morphological metric, the volume of each object, and this is actually the volume of the whole object. So we might want to do from the whole object means the entire reference channel mask inside each cell. So we might want to do on morphological metric on the sub-object, which means on each single separate object inside the cell, volume in voxels. And let's say we want to keep only the objects that are above, let's say 50 pixels. Okay, in this way we are telling SpotMAX, okay, keep only the objects inside each cell that are above 50 in terms of volume. And you can use all of these features, and you can use as many as you want. So you can add a new feature, select a new feature, do, I don't know, on the intensity, you think that the mean of the sub objects should be, I don't know, greater than 20. Actually, the intensities are from 0 to 1, so that's 0.2. And beside this, you can also say that it could be an OR statement. So SpotMAX, in this case, if I say this, it will keep those objects that are above 50 or that are also above mean 0.2. And if I use an AND, only the ones that satisfy both conditions. And you can have as many as you want. It obviously becomes hard above 2 features to select. So usually the easiest would be to segment without features, see what kind of artifacts we have, trying to get an idea of what could be a feature that describes the artifact, and then you can set that as a threshold. Or you could, for example, plot those features and see whether things cluster. So there is some kind of post analysis, data analysis to do to understand what kind of features, but once you have them, you can set them and you're good to go. So in my case, I don't need to set any features because you've seen the results looks pretty good, but in case you have a little bit more tricky, this is a good option. Save reference channel features, whether you want to save them in a table or not, that's good if you want to, for example, explore the features and decide which one could work best. Save reference channel segmentation masks, why not? It will save the file with the masks that you can actually then import into the GUI here, into the Cell-ACDC GUI, which will be this one here, or even this one, but it has less functionality, and look at the masks as you would be looking at cells. Save pre-processed reference channel image. This is a feature we added because we realized that when we wanted to publish, we wanted to show the steps, but we never saved the intermediate steps of pre-processing. So this is good if you want to show what are the pre-processing steps, the intermediate results, and you can save it as an additional image that you can also load, and it will be a TIFF file that you can load into Fiji, whatever software you want to use. So that's all for the reference channel. As you could see, the main things are these two. Which method to use and which thresholding method to use, and the rest is kind of easy to understand. Good. So we can move on to the spot channel. So we activate the spot channel, and again it's the same drill. We can share thresholding, which method of thresholding to use. I'll show you in a second all the results. We can use SpotMAX AI. This is a specific for SpotMAX. It's a UNet that we trained on a lot of images containing spots that of course needs more time for computing, but for tricky situations where thresholding is not enough, the AI would probably be better. And also it's trainable, so you could think of annotating some spots manually, generating the masks and train it. In the future, in the near future, we are planning to have automatic training from your own spots. So you could, for example, do spot detection with thresholding, then maybe clean it up manually to detect the false positives or to add some true positives, and then come back and train with those data directly from the GUI. And that is kind of a work in process. Even though the button is already here, it might not work well because we need to test it. In our case, we try thresholding. As before, we can click on this button. It will try all the thresholding and show us all of them. And as you can see, I'm probably interested in threshold yen or threshold li if we think we want to detect these 6 spots. So this comes down to your own biological expertise, whether these 6 here, 7, no, these 6 are actually spots or not. If they're true spots, you need to use threshold li, as you can see here. If they're not true spots, you probably want to go with Otsu or yen or ISO data. So in our case, I think Otsu is probably what I want to do. Doesn't really matter now for this tutorial, but let's go with Otsu because I don't think we need to detect these additional 5 spots that are in the background. But if you have to, then you see that with threshold li, you have them. So now you kind of understand that if you're starting to have spots that are not detected, there are multiple possible reasons. One is that the size is too big. So the size that you set to SpotMAX is too big. So then some are missed because they're too close to your other spot. Or you had a thresholding method that was too stringent. So if you wanted these 5 and you chose threshold also, you will never get them because they are outside of the spot masks. So at this step, what you want to do, you want to have the masks that are the smallest possible, but of course includes all of your spots because these, and if they include some false positives, don't worry because there is a second step where we can filter them out based on features. But the best this step is, the better the detection will be and everything will be smoother, which means it might also worth training the AI or just try if it works better than thresholding. So in our case, we go for threshold Otsu, but feel free to try also the AI or bioimage.io model if you find models that have been trained on spots. We actually published one of the models for SpotMAX on bioimage.io. And the other one is SpotIflow. SpotIflow is a recent method that has also been published for spot detection. It doesn't do any quantification, just the detection. But in some cases, it's actually pretty good. It's also easy to train. They have really nice library if you know a little bit of Python, of course. So it could be another option to go with SpotIflow and see whether the detection is improved compared to thresholding. But I always recommend trying with thresholding because it's much easier to understand, much easier to interpret, and it's also way faster than any uh, neural network, especially if you don't have a GPU. If you have a GPU, it's probably fine, but go with thresholding and see whether you can do that. Minimum size of spot segmentation mask. This has SpotMAX to remove all of those little artifacts that are smaller than 5 pixels. So if you have some false positives in the thresholding that are small, don't worry, you can remove them here at the segmentation mask level, not at the detection level, because the detection will be later. Spot detection threshold function, we decided on also. Spot detection method, there are two methods. Label prediction mask means simply just separating the objects in the mask, which could be enough if all of your spots are separated. Detect local pixel is the default because this allows you to detect multiple spots inside a single mask. So you could even have a spot segmentation mask that it's a single mask for all of your spots, and then on top of that mask you will detect local peaks. That can easily be done. Okay, now we can actually move on to the next, which is features and threshold. This is similar to before. For the reference channel, you can set which features to use to filter the spot. So if you have a true false positive, so detections that you want to remove, you probably need to go by intensities. So, and while for the reference channel you're kind of on your own, we don't have much guidelines. For the features, we have one specific feature which we use a lot. It's called the effect size versus the background or versus the reference channel, depending whether you want to compare the spot to the reference channel intensities or the spot to its own background. And usually the spots you want to remove are those dimmer spots that have been detected, but you want to remove them. And the way to do that is going by effect size. In the next video, we'll show you how to inspect the results and choose on an effect size level. But in our case, since we had those clean masks, we probably don't need any feature, but we use it a lot for single marketfish, so I recommend testing. And you open the effect size. You can either use glass, coin, on hedge. They have a slightly different variation, but they all in the end give you the same result. They might have a slightly different threshold. I usually go with glass effect size. They are explained on our documentation, so I will not take too much time here, but usually go with glass effect size and set it to more than some kind of level. Let's say 0.2. The way you know this threshold is by inspecting the results. So first you run the analysis without any filter, then you can load those results, load them into this tab here that I will talk about in the next video, and you can then hover onto the spot, see what the effect size of those spots is. Then you would see the effect size of the false positives that you want to remove, and you would see that maybe all the false positives are at 0.2, all the true positives are at 0.5. You would set the filter at 0.3, so then all of them will be removed. So this is kind of one of the main advantages of using SpotMAX. It has this filtering step. It's obviously not straightforward because you will need to know which feature to use, which threshold to use. We are planning in the near future to have a machine learning model that based on true positives and maybe even false positives that you provide, you need to label them as true positive, as false positive, so there is some time to train the model. Then there will be a model that tells you which feature would be more important for filtering out the spots, or you can use directly the machine learning model to use multiple features at once, basically to remove all the true false positives. Since that is not implemented yet, and we don't have, to be honest, it's not that hard to just inspect a little bit the results, spend some time seeing what kind of levels they have. You will be able to find the effect size. Usually it's enough for most of the cases. Anyway, we don't set any feature in our case. Local background ring width, this one we'll skip it for today. And some of these parameters, I plan to hide them in the more like advanced settings, but we don't have to discuss them now. Optimize detection for high spot density. I always recommend trying both because it depends whether you have a lot of spots or few spots. it might make a little bit of a difference in terms of calculation of the effect size. Especially you need it on if you have very bright spots that are close to very dim spots that you still want to detect. Then this optimization will try to remove the effect of leaky spots that are just neighboring bright spots, basically. But I recommend trying both on and off. Compute spot size. This is a computationally expensive step, so I recommend turning it on only when first of all, if you need these features, the features from the spot size, which are, you will see them in the documentation, they're separated into spot size and spot fit actually. So, but I recommend doing this only when you are 100% happy with all the parameters before. So first you do all of your detection steps, see that you detect those spots, and once you have that, you can run one last run with the compute spot size and see, get additional features like the spot size, other spot intensities, and basically in this step it fits a Gaussian curve to the three-dimensional spot, so a three-dimensional Gaussian function where it can instruct the diameter, the intensity, the volume. This is really good for knowing how much signal you have in each single spot and stuff like this. But I would do it only when at the end. So the specific features for SpotFit, I'm not going to talk about them today, but you feel free to read, of course, in the documentation. They are explained. You kind of get the idea now. All of these parameters, the info button, you can kind of try on and off, especially these are easy to just try on and off and see whether it changes stuff. You can have multiple run numbers, so you can run it as many times as you want and you don't lose your settings. And also don't worry about the settings for a specific run number, because I will talk about the output files in a moment. They will be saved. For each run number, they will be saved. The parameters will be saved, so you can always load them back and start from there. Okay, so this is also spot fit specific, merge spots where single pix fits better. You can try on and off and read about the documentation, maximum number. Save spot segmentation mask. As for the reference channel, we can turn it on and save them, save the masks. Features for the size of the save SpotMAX. So the masks have by default this value here, so you will get a spheroid with this size on each single spot that is being detected. So it's a fixed size, it doesn't adjust. So if you need additional spot masks that have specific size, you can click on this one and set the features like the size. No, I clicked on the wrong one. Here, you can click here on the and actually I just realized that I didn't want to set any features, but we actually did. Remove, deactivate. Okay, cancel. Yes. Okay. Good. So going back to here, features for the size, you can basically choose which size, which feature to use to generate the spot masks on top of the of each spot that has been detected. There is some features from spot size, from features from spot fit. You will have to read in documentation what they are, and you get different sized spots masks on each. And this is good if you need to do like co-localization analysis, when you need the masks of the spot and see whether they co-localize with some other signal. Okay. Now, save preprocessed spots image, whether you want to save the TIFF file with the preprocessed spots image. This is good for making figures, as I said before. You can have these and generate or whatever figure you want. And skip object where segmentation failed, you can leave it off for now and get errors if the segmentation failed for some specific cases where there are too many spots, for example, or the whole cell has been segmented, so there is some kind of optimization step there. The parameters for spot fit, you would turn them on. You probably don't need them because if you save the spot size, here you go, they're kind of the bounds for the fits, and I would go into this only if you are not happy with spot fit, and we can maybe have a video next time we're on the more advanced parameters, but for this time, for now, you can leave them at default because they work pretty well. Custom combined measurements, whether you want to generate additional features based on combining mathematically the other features. So for example, summing two columns, having the difference between two columns. And it's not that it's needed in terms of data in the table, because you could do it simply with adding two columns in post-processing. But it's good because then you have them for the filtering. So if you need a specific feature that is the combination of two features, you can define it here, and then you can use it for filtering the true spots, for example. And finally, we are at configuration. This is also quite standard stuff. The folder path of the log file. This is where the log file will be saved, and the log file is useful for me. If you have issues, I will ask you send me the log file. So if you save it in a place where you know where you save it, it's easier to find. The default is this folder here, which is in the user folder, SpotMAX app data logs, which you can also see from here. Open log file. It actually opens the log file in the notepad of the one that has been loaded now, and this is the file you have to send me if you have issues, because it has everything that is happening, and I would see errors and stuff that I want to fix. So technically you could just leave this default. You will be asked about this if it's missing, but let's go through quickly. Folder path of the final report. So SpotMAX will save a report, a very short report, where it will say whether there were warnings and errors. So warnings, usually most of the time you can ignore them. Errors instead, it's easy. It will tell you position 1 of this folder had an error. Very brief message of the error, but for me I will need the log file, but it's good to have a look at the report. And if you don't write anything here, it will be saved in the same location of the parameters file. The file name of the final report, if whether you want to give it a file name, or you can simply disable the saving that we can actually do for this tutorial. Disable the saving on the final report, so we will not get any report. Use default values for missing parameters. These are you would turn it on if you don't want to be bothered about the terminal. In the terminal, it will ask you, are you sure that you forgot this? Are you sure that, like, let's say we actually left here empty spot scores in the table 9 because we don't need it, but we might have forgot it. So if we don't activate this, we will be asked, are you sure that you want this empty? And you can just say yes. If you turn it on, it will not ask you anything. It will just assume you remembered everything. Stop analysis on critical error. I would leave it on for now, because then you will see it stops, and you can send me the error, because I don't exclude there will be bugs. But if you're running, let's say overnight, a lot of positions and only one has an error because of some very edge case, then you could turn it off. It runs overnight. In the morning, maybe you might see the error, send me the error, but at least all the other positions have been analyzed. Use CUDA compatible GPU. If you have a GPU with CUDA installed, turn it on, because some steps might be faster, like Gaussian filters, and actually only the Gaussian filter as far as I remember, but there are some steps that have been optimized to run on GPU. Number of threads used by NumPy, if you put it to -1, it will use half of the cores of your CPU to run. If you want to be faster on some steps, not all of them, you could set this to the number of cores that you actually have, but leave it to -1 if you don't know what I'm talking about. Reduce login verbosity. If you are somehow annoyed by the terminal printing too much, you want to see only progress bars, you could click this one and you will get way less information in the terminal. Okay, we didn't need to set up the configuration, but at least we went through all of them. So now at this point, you will be ready to press run analysis. However, it's recommended to save these parameters somewhere. As I said, they will be saved by the analysis, so don't worry about that. But you could save them as a master file, because you could have a master file that you run from, and you change that master file to try different parameters. The parameters will be saved for each run number, so you could have this master file where you just go in, because it's a little bit easy. It's way easier to change a single parameter from the file directly with Notepad instead of opening up the GUI just to change a parameter. And once saved, you can also load them. As you can see here, load parameters from previous analysis. You would select a file, and actually I think in the tutorial we have some files already pre-filled, and we have one for mitochondrial DNA, as I said, and one for single molecule fish. So we save them. It asks you whether you want which measurement you want to save. I'm probably gonna remove this at some point because I don't think anyone sets which measurements wants to save. I always say no, save all the measurements. Doesn't make sense to select specific one. But if you want a cleaner table with less measurements, you could potentially set and select which one you actually want to have in the final table. So we say no, we save all of them. We choose a file name. The default one is the timestamp analysis parameters. We select the folder. Let's save it here in the same folder. And now it says successfully saved. Here, if we do show in Explorer, I can show you it's here. It's this ini file, .ini, and we press OK. Now, we have this file here, which I can show you quickly. It's human readable. So you see all of those parameters we just went through, they are here. So let's say you want to change segmented reference channel from true to false, you would just come here and say false. There's no need to open the GUI to change these parameters. So you could set it to false and then maybe change the text open to the output files and the run number and get the run number too. So as I said, this could be your master file. You come in, modify, run it with a different run number, of course, and then you will get the actual run number file saved directly. And actually the analysis parameter saved for the run number will have an additional value here called source file. It will tell you that that file comes from this file, so you can actually backtrack where that run number was coming from if you didn't modify, of course, too much. So this could be your master file. Now we can say run analysis. We could browse loaded the save file, so you can basically click on this. It opens in Notepad, the ones that we just saved or loaded. We could load from previous analysis, but now we can run analysis. So it asks you whether you want to save because it forgot that you just did, or you might have changed stuff in the meantime. So just to be sure, ask you again. We say no. And now it says that it will run from this file that we just saved, SpotMAX -p. And this is the command that you can run in the terminal directly. So as I said, you don't need to fire up the GUI, load the data, go through this all the times you want to run SpotMAX. You could potentially just copy this file. Let's say we don't have the GUI open. You could go in the terminal. We open a new one. We say conda activate ACDC. And then we could paste that file, which is SpotMAX -p, and path of the parameters file. And if we press enter now, it would run directly. So we don't need to open the GUI essentially. So we could just modify a parameter in the notepad, come here and run it. However, I'll show you to run it from here, which I think I closed. So run analysis, we don't save it. Now it runs from here. You say, okay, run now. And as you can see, it will say SpotMAX analysis will now run in the terminal. All progress will be displayed there. Make sure to keep an eye on the terminal since it might require your attention. So now when I run it, the GUI disappears. And we can go into the terminal, which is here. So now it says SpotMAX analysis started with command SpotMAX -p. We wait a little bit. It goes through some stuff, and now as it just told you, keep an eye on the terminal because it will ask you stuff. So if you set up here the GUI now, it's obviously turned off because there is an analysis running. But let's say here, if you set use default values for missing parameter true, it will not ask you anything. It will just go straight through. Now it wants to be sure that you didn't forget stuff. So for example, how many threads of Numba you want to use. The default is 4. You also find out now that you have 8 cores in my machine. You could say 8 here if you want to use all. If you just press enter, it uses the default value, which is the one in the square brackets. So we could just press enter. Here it says the configuration file is missing the following parameters, which are the ones that I told you we skipped on purpose, but it wants to just make sure that you didn't forget them. So you can say yes, use default values. As I said, you could skip everything like this, but just to be sure, I usually go through. So here, do you want to continue with default value? The answer is yes, we want to continue. So the answer is number 1. We press 1 and we press enter. And now, as you can see, this is I did it on purpose. We actually have an error because I wanted to show you what happens when you have an error. You get these messages here, but the main one you will get at the end: error, not enough values to unpack, SpotMAX aborted due to error, more details in the following log file. So this one here is the log file that you should send me as soon as you get an error. You can send it to me by email or opening an issues on our SpotMAX page here, and make sure you send the log file. And this is something that can happen. It could be an easy bug. In this case, I just introduced a stupid bug myself on purpose, but this is what happens. So it says analysis ended with errors. See the summary of errors below, above actually, not below, and you would be able to send me this log file with the error. Now, thanks to Movie Magic, I already fixed it, and actually this gives me the opportunity to show you what we can do to run the analysis again. So we don't need to load the image data. We can just load the previous parameters files here, and it will tell you in a second parameters loaded. Exactly, parameters loaded. So, and we are back in business exactly as we left. We have all the parameters here, and I fixed the bug in the meantime. So we can do run analysis, say no, and it says run from this file instead. So we could run from this file. We can go here, and it says SpotMAX analysis started with command SpotMAX -p. Again, we can confirm the number of threads. We can say yes, use default values, and we just let it go. So for this is a fast analysis, and we are actually computing the spot size as well. Okay, so now it's finished, no errors. If it was an error, you would have seen an error message. SpotMAX analysis finished, started on, ended on, total execution time, in our case 20 seconds. We could say show log file, but we don't have to. We press OK. And now it says to visualize the results, load the image data, then go to the Inspect Edit Results tab and click Load Results from Previous Analysis. However, we will do this in the next video because for now you should have enough information to at least start the analysis and try some things and see how it goes, and mainly checking if you don't have errors, if everything runs smoothly, and then eventually report it. And I will leave my email address in the description box below, and some links, the documentation, maybe the preprint if you feel like reading about SpotMAX. If you're reading this from a future, maybe it has been published. So I will keep the description up to date with some links that I find useful. And until next time, bye bye.